Remainder and factor theorems. So the first part is pretty straightforward, and it has to do with the remainder theorem, and it has to do with something called synthetic substitution. Okay, and it is very much related to synthetic division. Okay, it's related to evaluating functions, and in the past, when we've evaluated functions, we've taken a value, plugged it in for x, simplified it all out, and then we get the answer, right? We've done that before, which we can still do, but in some of the problems that you're going to be working on today, you're going to be asked to use synthetic substitution. And first, I'm going to show you one through evaluation. We already know do a problem like that. The remainder from the synthetic division actually is the value. So it's like a problem like this. And of course, we know we could take 4, plug it all in, and we'd get a value, right? So I'm going to go through this part quick. You can skip some space and plug it back in later if you want. But the fact is when I plug that value in for the function, I would just get that, right? None of this is new. We've done this all before. Right? Take 4, plug it in, simplify it out, we get our answer. Okay, that's the evaluation way. What we can do is this problem using synthetic substitution, and essentially all that means is we're going to do some synthetic division, and I just want to help you set it up in order to do that. Okay. The key thing is that if I use synthetic substitution, we'll still get 662. Here's what synthetic substitution is going to look like. What I'm going to do is I'm going to do synthetic division, and I'm going to use 4 as my divisor. Okay, the same value. We're not going to change. So normally when we did synthetic division, we had this factor. We had to change the sign for the divisor. Okay, when I set up my dividend for synthetic division, what's it going to look like? Yeah, go. 3? No. Why is it not 3, negative 2, 5, 2? Yes?
You have to put 1 in for x squared.
Right. I don't have an x squared in here, so I got to have a 0. So my setup for synthetic substitution is going to look just like this. Here's, again, the key difference. Normally in synthetic division, we have to change the sign of this number over here, but that's only when it's a factor. This isn't a factor. This is the value that we're going to plug in and substitute. And what should happen is my remainder will be the same value I got as if I plugged 4 in, okay? Which we already know the answer, right? It's 662. So I want you to verify that that works. So do synthetic division on this. Okay, so here's what you should have gotten. Okay. Okay, and here's, and again, we already knew what the answer was through evaluation. That wasn't a big deal. The point is I want to show you why how synthetic substitution works. Okay, so my final answer is just that f of 4 equals 662. The remainder is the same value that you'd get if you would have plugged 4 in and simplified. No, that's half the lesson. Okay, so that's synthetic substitution using essentially showing you that synthetic substitution works the same way as evaluation. And in some of your cases, you're going to like this better than actually just plugging it in and simplifying. Okay, so that's the first part of what you're going to be doing tonight is some synthetic substitution. Are there any questions on that? No. Basically, the only difference is that instead of plugging in the opposite of the value for the divisor, we keep the number the same. All right, the second part we're doing is the oh, actually, yeah, you go ahead and do this one. Originally in this problem, it said g of x. That's why I changed it to f of x, because we're finding the value of f. So go ahead and do this one. My setup. Okay, so if you didn't have the right number of zeros, that could have given you one of your issues. I'm missing an x to the 4th term, and I'm missing the x constant, the x term. So if you missed couple things, okay? Remember that the number in synthetic division, the number of numbers that you will have is always 1 bigger than the degree. So the highest power is 5. I should have 6 terms. That's a quick little way to check to make sure you have the right number of numbers. Okay? So then when I go ahead and do that, you should get -6 for your remainder, which means f of -1 does equal -6. How many had that correct? Okay, very good. Theorem now. Now, factor theorem has to do with remainders, it has to do with factoring, and it has to do with synthetic division. It has all 3 components. And here's what it is all about. If a binomial goes into another polynomial evenly, meaning that polynomial divided by that binomial goes in even, the remainder equals 0, then that binomial is a factor of the polynomial. And if it's a factor of the polynomial, then I can find all the factors of the polynomial. So things that we were doing in 5.5 when we were taking polynomials and breaking them down and factoring them, we're going to be doing that also in this section. But usually they're not going to be as complicated as what you did in 5.5. So the types of problems that you're going to be doing related to this in your homework are going to look like this. There's 2 parts to it. The first part is showing that x minus 2 is a factor of x cubed minus 7x squared plus 4x plus 12. So that's the first part. The second part is going to be find the remaining factors. Okay? And I'll show you how to do both parts. So that x minus 2 is a factor of this polynomial, I just have to divide them. And when I divide them, the remainder should be 0. If that happens, when I divide this by this and the remainder is 0, then I've proven that x minus 2 is a factor. Okay? So what's the setup for this division? When I divide this by this, what's the setup going to be? I'm sorry? Long division or synthetic division? Which one do you want to use? Synthetic. Yeah, let's use synthetic. Okay? So what's going to go on the outside for the divisor? Positive 2, and then on the inside is going to be what?
1, -7, 4.
Okay? Just like that. Okay, so this is regular synthetic division with a factor, with a binomial, so I do have to change the sign. Go ahead and finish that. For it to be a factor, this remainder should be 0. Okay, go ahead and finish that. Yeah, watch your signs. Okay? Okay, so that's what you should have gotten. Okay? The remainder is 0, so I've done part 1. I've proven that x minus 2, I've shown that x minus 2 is a factor. Now, I have to do the second part. I have to find the remaining factors. What is this all about? What does this actually mean here? Okay, see what I really have right now. Okay, so I showed that what I really have now is x minus 2 times x squared minus 5x minus 6. Okay? So in order to find the remaining factors, because x minus 2 is one factor, how many factors should there be? It's the same as the number of solutions that there should be. What's the degree of this polynomial? 3. The degree is 3. That means there should be 3 factors. Okay? The problem is right now I only have 2. What do you think I'm going to have to do with this over here? Factor it. So that's what we're on the next page. So yeah, you need to factor that trinomial. I need factors of -6 that add up to -5. Okay? -3 and -2 do not equal -6. That's +6. -6 and +1. Okay? So, here's what we've accomplished. I know, I didn't. So this was one factor. These two are the remaining factors. Okay, so if it asks for the remaining factors, you would just tell me this. Those are the remaining factors. We proved that x minus 2 was a factor. The x minus 6 and the x plus 1 are the remaining factors. Make sure you answer the question. Okay? So the remaining factors, I'll just write this up here. Remaining factors are x minus 6 and x plus 1. Okay? That's the rest of this section.